From paper 1B, I will start a new chapter named as limits. Okay, it is under paper 1B. So limits and continuity. Okay, all of you know that definition of a limit. What is the limit? What is the function definition of a limit? Suppose if is a function small a over a deleted neighborhood of some real number is small, such that there is a real number L, right? So if to every positive number epsilon there exists some positive number delta such that mod of f of x minus L is less than epsilon, right? So for all x, then for all x such that mod of x minus a is greater than 0 and less than delta. Then we say that fx tends to, L as x tends to a, right? So that is limit x tending to a, f of x is equal to a. So this is the definition of limit, right? So here no one will ask definition with you in the examination, but you must have a concept. So before doing the problems, what is the definition of a limit, right? So what is the definition? Once again I will repeat. Suppose f is a function defined over a real number L, defined f is a function defined over deleted numbers of real number A and L be some real number. Okay. So if to every positive number epsilon there exists some number delta very small such that there exists a positive number delta such that mod of f of x minus L is less than epsilon for all values of x such that mod of x minus a greater than 0 less than delta. Then we say that fx tends to L as x tends to a, that is limit extending to a fx equal to a. So this is the definition of limit. Okay. Now after this you know that right hand limit and left hand limit and left hand limit. What is right hand limit? Right hand limit. What is right hand limit? Limit extending to a plus, right? F of x is equal to L, or limit h tending to 0, f of a plus h is equal to L, right? And what is left hand limit? Left hand limit. If limit extending to a minus f of x equal to L, or limit h tending to 0, f of a minus h is equal to L, right? So sometimes both right hand limit is equal to left hand limit, then we say that limit exists, right? Okay, so this is called the right hand limit and left hand limit. Okay, infinite limit. What is infinite limit? If the limit is extending to infinity, right? Extending to infinity, then we say that they are called the infinite limit. Okay. Now, after that, what is indeterminate forms? You have word missing this word, indeterminate form. Indeterminate forms. What is indeterminate form? That is 0 by 0, 0 by 0, infinity by infinity, comma 0 into infinity, comma 0 power of 0, comma 1 power of infinity, right, are called the indeterminate forms. Indeterminate forms, right? Now, then standard limits. You know the formula of standard limits, right? What is the first standard limit? This is very important formula. Limit extending to a x power of n minus a power of n divided by x minus a is equal to na to the power of n minus 1. Right? This is just basic fundamental formula. Right? What is the limit? Extending to a x to the power of n minus a to the power of n by x minus a. Right? Second formula is limit extending to a x power of m minus a power of m whole divided by x power of n minus a power of n is equal to m by n into a power of m minus n. Here m is greater than n. Already you have by hand this formula. Just I am revising this formula so that it is a brush up class. Already you studied this class himself classes. Now we are just brushing so that you can prepare for the examination. Okay. Next formula is limit extending to 0 sin x by x equal to 1. Limit extending to 0 tan x divided by x is equal to 1. Okay. Then limit extending to 0 sin of ax divided by x is also equal to a, and limit extending to 0 tan of ax divided by x is equal to a. Okay. Limit extending to 0 limit extending to 0 sin x power of degree, sin x degree by x. So 1 degree is equal to pi by 180 radians, right? So limit extending to 0 tan x degree by x is equal to pi by 180. Okay. Now limit extending to 0, extending to infinity, 0 is over, sin 0, limit extending to infinity, sin x divided by x is equal to 0, and limit extending to infinity, cos x divided by x is equal to 0. Okay. And next is limit extending to 0, sin inverse x divided by x is equal to 1, and limit extending to 0 tan inverse x divided by x is equal to 1. Eighth one, limit extending to 0 e power of x minus 1 by x is equal to 1. Limit extending to 0 a power of x minus 1 divided by x is equal to log a to the base e. Right? Limit extending to 0 a power of x minus b power of x divided by x is equal to log a by b to the base e. Extending to 0 a power of x minus 1 by b power of x minus 1 is equal to log a to the base b. Okay. So these are the standard limits. Now there is a formula named as L'Hospital's rule. Right? So the purpose of using this L'Hospital rules is very important. Right? L'Hospital rules. Whenever I want to simplify the question in less number of steps in seconds, so I have to use this formula named as L'Hospital rule. When I have used this formula means suppose the given limit is of the form of fx by gx. And when I apply the limit, I am getting the answer as 0 by 0, right? If limit extending to a fx by gx is given. So if I apply the limit, then I am getting the answer as 0 by 0, or I am getting as infinity by infinity, or any indeterminate form. Any indeterminate form. So in this case, what I am doing, I am differentiating this numerator and denominator. Then I substitute the answer. So I may get the option. I may get the correct answer. If again on differentiating, so this is limit extending to a f dash x by g dash x. So I may get the answer as my option. If again f dash x by g dash x is again is equal to 0, then in that case, and it has become the indeterminate form, so I have to differentiate again, right? So that is find limit extending to a f double dash x divided by g dash x, right? Well, suppose if on substituting the limit, I am getting again this is also an indeterminate form, then I have to go for f triple dash x by g dash x and so on. Okay, so this is the process called L'Hospital rule. So the advantage of this is within 1 or 2 steps only we may get our goal, we may get our answer, right? So write down next. Limit x tending to 0, 1 minus cos x by x is equal to 0. These are the important results. You have to memorize this. Limit x tending to 0, 1 minus cos x, 1 minus cos ax by x is equal to a square. Right? Right? So next is limit x tending to 0, 1 minus cos nx by 1 minus cos mx is equal to a square by m square. Similarly, limit x tending to 0, cos ax minus cos bx divided by x square is equal to b square minus a square divided by 2, right? Similarly, limit x tending to 0, cos ax minus cos bx divided by cos cx minus cos dx is equal to b square minus a square divided by d square minus a square. Okay. Now, one more important result is there. Very important is, suppose gx is any form. Suppose if gx is equal to in any one of the form, either x or sin x or tan x or sin inverse x or tan inverse x. So you know that the external limits are only for sin theta and tan theta, not for cos and sin. Similarly, sin inverse x and tan inverse x. Therefore, if gx is equal to x or sin x or tan x or sin inverse x or tan inverse x, right? Or sin hx, hyperbolic x, or tan hx, etc. Then, so this is the formula useful for all these functions. Wherever gx is any one of these, you can use this formula. That is limit extending to 0, nth root of a plus x power of n minus mth root of a minus x power of n divided by g of x whole power of n, right? G of x whole power of g of x whole power of n is equal to 2 divided by m. What is m? Into a power of 1 minus 1 by m. Right? So what you have to remember? Limit x tending to 0, mth root of a plus x power of n minus mth root of a minus x power of n divided by gx power of n is equal to 2 divided by m into a power of 1 minus 1 by m. Gx can be taken as x, or gx can be taken as sin x, or gx can be taken as tan x, etc. It depends upon the requirement of the problem. So whatever the question comes, you see this and substitute. Okay. So this is the first formula. Based on this, I will take some question, and as soon as the other formula will come, I will give later on before solving the questions. Now write down a problem. First question. Limit x tending to 0 sin pi cos square x divided by x square. The answers are minus pi, pi by 2 and minus pi by 2. Right? Now, if I apply the limit, what is the limit? 0. If I apply the limit 0, cos 0, 1. Right? Pi, sin 0, 0, cos 0, 1. 1 into sin 1 by x square. What is x? 0. So, what I am getting? I am getting the answer as 0 by 0. So, I am getting the indeterminate form. Right? Therefore, what I am doing, as I told you, whenever you are getting indeterminate form, you have to apply L'Hospital. So, on substituting x tending to 0, we are getting as indeterminate. Apply solution. Apply L'Hospital. So, what is L'Hospital rule? So, I have to differentiate the numerator separately and denominator separately. For example, it is in the form of sin x. What is value of sin x? Cos x, that is cos of pi cos square x. Okay, into now the derivative of inner part pi will remain as it is. Now cos square x is nothing but 2 cos x into derivative of cos x is nothing but minus sin x whole divided by derivative of x square is 2x. Okay, what I have done? I have differentiated separately the numerator as well as the denominator. Now, what is the limit? X tending to 0. Now, if I apply the limit x tending to 0, see what happens. So, first of all, what I am doing, I am just simplifying this. Okay, limit x tending to 0. This minus pi will take on outside. Pi will take on outside into cos of pi cos square x. Okay, into what is remain? Cos pi square x. What is remain? This cos x will be there, and you see that 2 from the numerator, 2 from the denominator, it will be cancel each other. So here 1 sin x is there. So I am separating this and applying the limit x tending to 0, that is sin x by x. Okay, is equal to, now if I apply the limit cos 0, 1, right? So this is minus pi cos 0, 1 into pi cos pi is equal to minus 1. So this is nothing but minus pi into cos pi is nothing but minus 1 into this is sin x by x is equal to 1 into 1, which is equal to pi into 1 is nothing but minus pi. Minus into minus is equal to plus pi. Therefore, my answer is pi. Okay. So my option is second option. Now you see, observe that question was very big, but it has been simplified into only 2 steps. So by using the L'Hospital rule. Okay. Now come to the next question. X tending to 0, cube root of 1 plus x minus cube root of 1 minus x divided by x. The answers are 1 by 3, 2 by 3, 0 and 1. Now, if I apply the limit, x tending to 0, this is 0, 1, cube root of 1 is 1, minus this is 0, 1 minus 1, 0, 0 by 0, nothing but it is an indeterminate form. So 0 by 0 is an indeterminate form. Okay. Now, as I approach to indeterminate form, what is my duty? I have to differentiate the numerator and denominator, right? Separately. So I am doing the same thing. Okay. Is equal to limit x tending to 0. This cube root of 1 plus x is nothing but it is a form of x power of n. That is 1 plus x whole power of 1 by 3. So what is the derivative of 1 plus x whole power of 3? Is n x power of n minus 1. What is n? 1 by 3 minus 1 into the derivative of x is 1. Okay. Minus again. This is again in the form of x power of n. So 1 by 3 into 1 minus x to the power of n minus 1. That is 1 by 3 minus 1 into here this is 1 minus x. Derivative of 1 is 0. Derivative of x is minus 1. So this is nothing but minus 1 whole divided by derivative of x is 1. So this is equal to if I put x tending to 0, this become 0. If I put x tending to 0, this become 0. So this is nothing but 1 by 3. This is nothing but 1. 1 power of 1 by 3 is 1 only. Plus this minus 2 minus plus, so which is equal to 1 by 3. 1 by 3 plus 1 by 3 is equal to 2 by 3. Therefore, my answer is which option? Second, 2 by 3. 2 by 3 is my second option. Is it clear? Now, come to the next question. This question was asked in 2019. X tending to 0, square root of x square plus 100 minus 10 whole divided by x square. 0, 0.1 minus 0.05, 0.05. So these are the 4 options, right? Now, what is being given? Extending to 0. Suppose if we apply extending to 0, this is 0. 0 plus 100. 100. Square root of 100. 10. 10 minus 10. 0. So 0 by 0. So again, I am getting as indeterminate form, right? Therefore, I am applying the L'Hospital rule. Okay? Applying the L'Hospital rule. LH rule. I will write in short form. Okay? Is equal to limit extending to 0 as it is. Now, root of something 1 by 2 root that thing, that is x square plus 100 into derivative of inner part, that is derivative of x square is 2x, derivative of 100 is 0. Okay, minus derivative of 10 is a constant 0 divided by derivative of x square is nothing but 2x. So you see that this 2x from numerator, 2x from denominator cancel each other, which gives me limit extending to 0 1 by 2 times root of x square plus 100. Right? Now, if I apply the limit extending to 0, this becomes 0. So 1 by 2 into root 100. Square root of 100 is nothing but 10. So 1 by 2 into 10 is equal to, the answer is, if you divide this 1 by 20, you will get answer is 0.05. 0.05. Limit extending to 0. Limit extending to 0. Tan cube x minus sin cube x whole divided by x power of 5. Right? The answers are 5 by 2, 3 by 2, 3 by 5, 2 by 3. Right? This is also asked in 2019 examination. What is the question? Limit extending to 0, tan cube x minus sin cube x by x power of 5. So there is a standard, there is a shortcut formula. There is shortcut formula, you remember this. So in such type of question, directly you can apply the formula and get the answer without simplifying this. What is the formula? Limit extending to 0. Limit extending to 0. Tan power of nx minus sin power of nx divided by x power of n plus 2. N plus 2 is equal to n by 2. Right? So, if you compare this problem, this formula, the given problem, what is my given problem? Tan cube x minus sin cube x by x to the power of 5. X to the power of 5 can be written as x power of 3 plus 2. Right? So, therefore, tan nx minus sin nx divided by x power of n plus 2. The answer is n by 2. Therefore, here my answer is, what is n here? 3. So 3 by 2. Therefore, my answer is 3 by 2.